Let's talk about number 5. What is the frequency? And that is the Greek letter called nu in our formula of the electromagnetic radiation. In other words, the light, even if you can't see it, maybe it's microwaves, maybe it's ultraviolet, maybe it's gamma rays. Having a wavelength, remember that is our Greek letter called lambda, of, and they just told us the meters. They just told us the wavelength. What is the frequency? What formula do I have that relates frequency and wavelength? It's this one. Here's the speed of light, the wavelength, and the frequency. And you don't have to memorize formulas, but you are expected to know what to do with them. Here's the speed of light. It's just given at the top of the page. Here's the wavelength that they just handed us. Here's the frequency that I don't know. I divide this under, and I get this number divided by that number. The meters will cancel out and give me per seconds. Now, what kind is that? Well, it actually turns out to be really, really small, and it's off to the scale to the right, but radio just continues off into kind of down to 0. So it's radio. 6, a lamp emits radiation with a wavelength. Wavelength is lambda, and they give me the wavelength. What color is that? Go look on your electromagnetic spectrum page. And what we're going to see is that it's in the range where it might be visible. It might be visible, so go take a look, hit pause, go take a look. And so if we're going to see if it's visible, let's convert it to nanometers, and nanometers are 10 to the minus 9. Now we're going to go way back to August for this one, I think, but I need this to be 10 to the minus 9 meters, which is nanometers, so I can see if it falls into that colorful spectrum that I can see as a human being. So I need to change the E number, the times 10 to the number, from -7 to -9. That just got smaller by 2 decimal places. And what you might remember is that if this gets smaller by 2 decimal places, this has to get bigger by 2 decimal places. So what I now have is 580 times 10 to the minus 9 meters, or 580 nanometers, or sometimes just written nm. And if you look on the colorful portion, you will see that that is probably in the yellow part of the spectrum. Calculate the frequency of this radiation. Well, they gave me wavelength. I always know the speed of light. Here's frequency, divide, and I will get the frequency. Again, the meters cancel out and leave the unit as per second. A line on the emission spectrum has a frequency. That is nu. Calculate the wavelength. That is lambda. Same formula. I'm just finding lambda, divide. Oh, this is supposed to say meters per second. Oops. The per second parts cancel out and give me meters. When an electron falls from the 4th to the 2nd energy level, it emits a photon with a frequency of this much. Calculate the energy. Well, here's my energy formula from the top of the page. What's the energy? I don't know. So it's sort of unknown x. What's h? It's always this number. It's at the top of the page. Notice that the units are joules times seconds. What's the frequency? They told me that. Remember, frequency is Greek letter nu. So I can just take this and put it here and just multiply. Now, the per second on the bottom will cancel out the seconds that's on top of the fraction, and some of you said, that's not a fraction. Well, everything's over 1, isn't it? Anything can be over 1. So this is on the top of a fraction if we count the bottom as 1. So this seconds will cancel out that seconds and leave me in units of joules, which is good because back on the first video I said the standard scientific measurement of energy is in joules.